Yes, so hello friends. Today I'll be explaining the LeetCode 401 problem binary watch. So it's an easy coding question. So the problem statement is like, so we have the binary watch which has the four LEDs on the top, which represents the hour, and the hours are ranged, as we know, it's from 0 to 11. And the next below that there are six LEDs which are representing the minutes, which are from 0 to 59, and each LED has the represent 0 or 1, which means it is either on or is it either off. So based on this, we have to find the problem is that there is given a one integer which is named as a turn on, which represents the number of the LEDs that will be currently on. So we have to return the possible different times that watch could represent between these LEDs numbers, known as turn on. So basically we have to find out all the possible timings which will be having the LEDs on. The number will be equivalent to the turn on. So there are some constants given, the hour could not be contain the leading zero. That means you can see over here the example. So it's a 0 1 0, like a 1 or 0 0 is not valid, it should be 1 0 0. And the minute also consists of two digits and may contain the leading zero. The like this you will see the 10 2 is not valid, but it should be the valid is 10 0 2. So accordingly I'll just explain this the example. When the turn on is equivalent to 1, that means the only one leading zero will be the on, either it will be a minute or either it will be a second. So here you can see 0001, and we are here, you can say from 1 to 32, we are 1 to 8, we are adding 00 over here. So it will be 001 002 or 004 or either 008, then till that 032, then 1248. Like this, the number should be, only the one number should be on. So for this you can see over here, like we have four digits, so either this four, the one number should be on, or from this six, the one number should be on. So like this we have to represent the all digits, right? Then here they have given some hints, like seek by simplify the solution, seeking for solution that involve the comparing bit counts and consider the calculate all possible times for comparison purpose. So here there is one simple naive approach we can use, is like that we can just calculate, like take a loop from 1 to 4, like 1 to 11 hours and 1 to 1 to 60 minutes. And based on that we can just there will be a 12 into 60 scenarios, and we have to just calculate either the number of the set bits. Like set bit is the basically the one in the LED is for the minute and second. Addition of both the numbers should equivalent to the turn on. So I'll just explain it using the code. So firstly we'll just add the string where we'll store our result. So we just write it down. Then here you can also see there is one more example where turn on is equal to 9. So you can see when the 9 digits are on, so here totally 10 digits are there, right? So if we can say the 9 digits are on, so we cannot do this by any condition. Even if you say like from hour, if we cancel any one, so if we cancel 8, then 4 to 1 if we are taking, then from the minute, if you we cannot take the 30 to 16, like all the six digits, then it will be, the value should be greater than the 59. So we have to cut one digit, either from this or this. So you can say the minimum we can take the digits, LEDs lights are 8, not 10. So we can add one constant as like, if the turn on value is greater than the 8, then we simply return the answer, which is the empty. Okay, then go down, we'll start one for loop of hour starting from 0 to hour less than 11, and then hour plus plus. So we have the 11 hours. Then from going from 4, for int loop, where we are taking the minute, which starts from 0 to minute less than 60, minute plus plus. Here it will be, we can write it as a 12. Okay, so now will go down. We'll check the condition if then for calculating the ones, like the in minute or second, the value of the one. Sure. Just calculating the set bit, so we'll just use one math library function, which is like the um which is like the simple math function, which we'll use as the that value will be built in pop count. So taking the value of this r plus, we can add the built-in pop count minute value should be equivalent to the turn on. So basically what this function is doing, built in pop count, it is calculating the total number of ones in the led button. So like if there is 8421, so it is calculating the one value. So here you can see 001, 002, or this is, so it is just calculating the one number. So here you can see it's 0 and 02, there is only one value. Like this, it is calculating the on button values. So that then we'll just check if the value of this is equivalent to the turn on, like the then only we'll proceed. We'll just take the one string as a time, and here we'll just convert our hover, uh, sorry, to the string. um, just convert our hover into the int hover into the string. Along with that, we'll just add this column, um, just for formatting. Then we see the condition. If there is, then we have another condition, which is like the minute must consist of two digits. That's why, so that means if the minute is less than 10, then we'll just have to add the 10 over here. So that will just will add over if the minute is less than 10, so that this condition will verify. So you can see that whenever the minute is one digit, that means the less than 10, then we'll just adding the one we are just adding the 0 over here. So you can just add the 0, right? And then again, then next we are just adding the our two string minute. Okay, so this is how it is, and then we are just pushing this minute into the our answer. So we'll just push this answer dot push back time. This value we are pushing into the vector string. Okay, and then we are just returning it the answer. Okay, it works, right? And we are pushing this answer over here only inside this loop, so that whenever we have this value, we are just pushing that time into this, because the scope of this time is over here in this for loop only. Okay, so this is the overall code. I'll just run it. I hope the all test case will run. So here you can see that all the test cases are running, and I'll just submit this. So here we can see if it is running. Yeah, so here all the test cases are running. It is completely fine. Then the next one is the time complexity for this code will be, I'll just write down over there, is the tc is, we are calculating the hour for 12, like minimum 11 into the minutes are like 16. So if we can assume like less than 60, it's 59 basically, right? So the total count will be equivalent to the some number which will be a constant. The value should be equivalent to 11 into 59, it's 649. So it's again constant. So basically the time complexity will be big of 1. So it's big of 1, right? um, and the space complexity is the only the where we are storing our result, which is also equivalent to the big of 1, which is also big of some constant, right? um, so which is equivalent to the big of 1. So the overall time and space complexity, we can say it's a big of 1. Okay, so yeah, that's it from my end. This is the overall code. I hope you guys have understand this simple problem. It's very easy. Just remember, this is the built-in function we have used in the C++ library. There are different same functions in the other languages as well. I'll just add over here to see the what is this function do. So if we can go and you can see this link as well. I'll share this link along with you in the video channel as well. So here you can see this function is used to count the number of set bits in an unassigned integer. In other words, it just counts the total number of ones in the binary form of a positive integer. So I hope you have understood